Toma Vele from programtom.com/dev here, and in this episode I'm gonna show you the task that I've coded. It is available on GitHub. So here is the README file. It showcases what it uses, what it requires, some scripts for building, and what I've coded, like 2 ways of communicating between the microservices, and some side notes about code quality and code coverage. So I'll run the microservice once with and the latest version I've published exposes generating new items from endpoint localhost generate, and it does the job. And here are the new input and output CSV files that do the work, do the filtering of prime numbers. So the entry point is the producer, and the producer has an endpoint that just hits random number generator wrapper. And I've left commented another way of generating random numbers. Basically, if I don't want to expose this, and if this is removed, potentially this exposure from Docker Compose will also be not required, basically. So this goes generate and send. So it's a pretty straightforward logic: generate numbers, generate name, and send the batch of numbers with file name to the other side. And I've implemented 2 ways of communicating between them. So the one is that's currently active. It is marked with primary implementation of number communication. Just sends a HTTP post endpoint grabbed from application properties. So it could be overwritten by Docker Compose. And the other way is with RabbitMQ communication. So it uses RabbitMQ template to send the random number with a RabbitMQ message, and the location of RabbitMQ is set in Docker, like here, having a host. And yeah, another important thing is setting the externally where the CSVs will be saved, and mapping the volume so the output could be saved outside of Docker. So yeah, so this is the producer side. It's very straightforward. This consumer, and random number service just generates 100 numbers with 5 numbers per second max, and it sleeps. And basically this site, maybe what's left to show you, the scripts to build here, it use Maven to package jar, and the other command, docker build, produces a Docker image that Docker could pick up a container from it. So this is a very simple Docker file. And the consumer could be exposed in two ways: via a REST endpoint or with a RabbitMQ message listener. So for now I've commented this code and also the config, but yeah, if you want the RabbitMQ version, this needs to be uncommented, and yeah, it just consumes number, filters them by prime, is prime, and writes them to CSV as output. And here the CSV file, very similar to the previous, it just has different suffix. Out. So here is the logging configuration and the root directory. So what else to show you? The model is the same. Let me show you the output of the code analysis. So basically on the consumer, I could hit mvn clean test, and this will output a code coverage report. And generally I've strived to get a 60% code coverage, but yeah, I've left minimum to be 30, as I didn't write all the unit tests for OD and all the stuff. And yeah, I could potentially have a test that will call the endpoint, that will call the consumer endpoints, and it will go down to what is, and yeah, it will code the logic below, but yeah, I've left it as for now. And here is the target site. Yoko index, and it gives nice report what package has what coverage. Patch number service, prime number service, and yeah, it's total 57%. It's not bad, but it could be better. And another thing that could be enforced here is spot bugs. This static code analysis that finds smelly code. And This is a plugin for Maven that does that at some goal that could be executed in a CI setup. So no errors warnings found, and all the code could be seen on GitHub, so you could check out some very simple tasks that could be implemented with more complex architecture, with communication between two microservices, and I've showcased some quality assuring plugins that is executed on your code. So this is the personal code review of the task, and yeah, I've sent the task and we'll see how it goes.